All right, this is to help you with AP Workbook, page 135 and 134. So just to recap what impulse means. Impulse is the term given to the force that's applied to an object or system over a certain amount of time. So if you find the area of the force time graph, that is the impulse, right, that an object experiences, and the impulse causes a change in momentum. So you can calculate the change in momentum of an object from F delta T. So now going back to this graph, okay, you're asked on page 135 to plot the momentum as a function of time using the impulse information from this force time graph. So what I've done here is I've kind of color-coded it 1 second at a time to help you understand how you can find the total change in momentum, because it's a cumulative effect. I think a common mistake would be to think that there's no change in momentum between 2 and 5 seconds because the force applied is constant, but the object is actually going to experience acceleration that entire time from 2 to 5 seconds because the force is continually applied, so the object keeps accelerating, which is a change in velocity, which is therefore a change in momentum. So there is definitely a momentum change. So let's start building the change in momentum of the object. So if it's starting from rest, it has no momentum to begin with, and let's look at 1 second later. So 1 second later, the object would be moving faster because it experiences a force, right? And we can find the change in momentum from the impulse of this little triangle right here. The height of this triangle is 1.5 units, and the base is 1. 1 times 1.5 is 1, divided by 2, because it's a triangle, is 0.75. Okay? Now, 2 seconds later, let's change this to total change in momentum. 2 seconds later, the total change in momentum from rest, right? We'll even make that from rest, would be a cumulative effect of every second. So now we have the 0.75 from the first block, and then now we've got this block right here. So this is a little trickier because it's a trapezoid. I can see that this triangle at the top is actually the same as this triangle down here because the slope is constant. So that's 0.75, and then the area of this rectangle down here is going to be 1.5 times 1. So we'll have 1.5 plus 0.75. So the area of this orange area from 1 to 2 seconds is 2.25. 2.25. So then we'd have a total of 3.0. Now from 2 to 3 seconds, right? So we have the 3.0 already because the momentum is increasing due to this continuous force that happens to be growing. Now the force levels off, but because the object's experiencing a force, the net force, it's going to experience a change in momentum. So the area of this would be 3 times 1. It's just 3. So the total change in momentum would be 6 from the time that it starts, and so on and so forth. So if you're going to use this information to create the graph on this portion right here of the workbook, and notice that it's going to be growing. Whoops. It's going to go 0, then 0.75, then 3, then 6, right? And then it's going to slow down towards the end. So I think the overall curve should curve and then be linear and then curve. So it should be like an S-shaped curve.